Hi everyone, thank you for joining me today. We're going to be talking about section 4.3, which is polynomial functions. This is going to be kind of like the introduction to composite functions. Hope you guys are having a great new year so far in January. Let's go ahead and jump right into it. Here we have adding and subtracting polynomial functions. We did this in section 4.2, but now we're going to like explicitly write it out in a new way. So here we have this, f plus g of x. Anytime you see that, don't panic. It's much easier than you think. It's the same thing as adding f of x plus g of x. It's as simple as that. So if you had, like for example, f of x equals x plus 1, and then g of x equals, I don't know, let's just call it x squared, then f plus g of x, f plus g of x, and that's how you say it, f plus g of x, would be equal to simply x plus 1 plus x squared. And of course you would want to write it in standard form, so it would look like that. It's the same thing. So you just add the two polynomials together, the two functions together. And it's the same thing if we have f minus g of x, then it's going to be the same thing as f of x minus g of x. So pretty simple there, nothing too complicated. And now we are going to talk about the domain of the new function. So after we get done with this addition or this subtraction, we're going to have a new domain. Okay, you're always going to have a new domain, the possible x values of the function. So if you combine them, add or subtract, you're going to have a new domain, and it's going to be where there's, I'm going to keep this color, where the intersection of the two functions. It's where they intersect is going to be the new domain. Okay, so if you're graphing, that would be a good way to see that. And we're going to talk about that maybe a little bit later, but this is just the basics for this section. Okay, example 1. I think this is the best way to learn this, is just get into the nitty-gritty, so let's go ahead and do this. Here we have the two functions, so we have our, let's change the color here, make it a little bit more colorful. We have f of x, and then we have, let's use a different color, let's use this green, I like this green color. And we have g of x. Okay, so we're talking about f plus g of x. Like I said earlier, all we need to do here is add the two functions. So what we're going to do is we're simply going to say, okay, this is the same thing as f of x plus g of x. Okay, and we have the values for this. We're going to say equals. We already know that f of x is equal to 10x squared minus 2x, and then we're just simply going to add this 2x. What happens when we do this? Well, it's going to simplify. I was using a different color blue, this one. It's going to simplify because these two combined, those are like terms, and we're going to be left with 10x squared, and that's going to be our answer. So as we said earlier, we're going to have a new domain based on the intersection of these two functions after we add them together. And the new domain is going to be related to this guy, not to the previous functions before, okay? So the domain is going to be related to 10x squared. But that's how you do it. You simply add the two functions together. Now, that's when we have x. So we already had x expressed with these two functions, but now it's asking us, okay, what happens when we have, oops, not an eraser, didn't mean to do that. What happens when we have a 2 in there? So now we have a 2, so what do we do, okay? Well, we said before that f plus g of x is the same thing as f of x plus g of x. So what is f plus g of 2 going to be the same thing as? This is going to be the same thing as f of 2, I think I'm going to do this, yeah, like this. F of 2 plus g of 2. Okay, so it's like the same thing. Before, when we had like f of 2, we would plug in something into, like, let me just give you, I'll do g of 2. So if we had like g of 2, you just plug in 2 into g. Now if we have f plus g of 2, we have to plug it into both g and we have to plug it into f. So we plug into both functions. Okay? So let's go ahead and show that next step. Let's switch over to pink again. No, I was using blue. We use a different color. Same blue. Be consistent. Consistency is important. So we have 10 times, but now we don't have x squared, okay? Now we're going to replace this x squared with 2. So we're going to have 2, comma, not comma, parentheses squared. Okay, we substituted this into the function. And then minus, don't forget about the second one, I almost did, minus 2, okay? That x, okay, is that 2 now. Plus, over here, we're just going to say what g of 2 is. We already calculated it, but if you want reference, we just plugged it a 2 in right there. Plus 2 times x, which is going to be 2. So we see we replaced it in each one of those. Now we're just going to simplify. Okay, so we have 2 squared, exponents first. 2 squared is 4. Minus 2 times 2 is 4. Plus 2 times 2 is 4. We get 40 minus 4 plus 4, which is the same thing as just 40. So 40 is going to be our answer once we do that. Now, another way to do it is, since we've already done f plus g of x, okay, we could either plug in 2 for f, 2 of g, and then add them, or we could just take our function f plus g of x, we already know what that is, and we could plug in 2 into that. So we said f, let me show you. It's high level, so I just want to make sure we understand it. We already know that this is equal to 10x squared. We already solved it. That was our first one, letter A. So if we want to find f plus g of 2, another way to do this is simply just plug in 2 into our function there. So we have 10 times 2 squared. So 2 squared is 4, 10 times 4, and we get 40. We got the same thing. So there's 2 different ways to do the same problem. I think most of my students prefer the first method I showed, just so I think it a little less work. So if you want to use that method where you just plug it into both functions and add, I think that's a good way to go. So now we have, so you guys get it a little bit better now, and I'm going to switch over to blue. F minus g of 1. So what we're going to do is we're going to plug in 1 for f, we're going to plug in g for 1 for g, and then we're going to solve. So we have 10 times 1 squared minus 2 times 1. That's my f of x. Okay, f of x. I just plugged in 1 because it's asking me to plug in 1. But now I'm going to subtract, and it's very important that we put parentheses here, because we're going to be subtracting that whole value. So if there's addition or subtraction, we have to apply that minus sign and distribute if necessary. Be prepared for that. This one we don't have to because it's only one term, but it's a monomial, but be prepared for that. And then we times 2 times 1 because we're replacing x with 1. We go from here. 1 squared is just 1, so we have 10 minus 2 times 1 is 2 minus 2, so we have a little bit different answer. We have 6 this time because 10 minus 2 is 6. Okay. I'm trying to decide if we should just keep going. I think I'm going to stop the video. No, we're going to keep going. We're going to plow through because it's not that bad from here. All right. So now we're talking about, let's switch over to red, composition of functions. So composition of functions is a little bit different. Literally what this symbol means is composition, okay? So anytime you see that little tiny circle like that, it's not a 0, it means composition. I know it looks like fog and goth, but that's not what it's saying. This simply means f of g of x. It's like a compound, composition. It's 2 and 1. And this is f of g of x. That's how you say it. Now, how do we handle this? Well, how we handle it is we see that there's 2 parts to it. And let me get the different colors here. We have 2 parts. We have the g of x, okay, and let me get another color. And then we have the f of x. So it's kind of like a big, I'm going to do this faintly. It's kind of like a big f of x. what does this mean? Well, this means we have an inner function, okay, the inner function, and then we also have an outer function. So this is our outer function. This is clearly our inner function. So how do we handle it? Well, we start with the inner function. So we start, where should I write this? I'll put it up here. We start with inner function. Okay. We are going to get a result. Okay, anytime you plug in something to the inner function, you're going to get a result. Let me move this over. Then you, from that result, you're going to plug in to the outer function. And then you're done. Okay, you're going to get a result for that. Okay, but this is the process. So hopefully this makes it a little bit more clear, but once we put it into practice with these examples, it'll be a little bit more obvious, I think. Okay, so I'm going to actually erase this. You kind of get the idea. We have an inner function, outer function with composition of functions. So let me just kind of reiterate it here with this one. Now it's G composition of F, G of F of X. So this is like on the outside. So the inner function this time, can you identify the inner function as I write this? Hopefully you said the inner function this time was f of x. So f of x was the inner function here. Let me get my orange. And then g of x is the outer function. So we always kind of start with the inside out. So the inner function, we have inner here. That's the inner function. That's the inner function. Is the one closest to x. So the one closest to x is the inner function. And then we have our outer function that's further away from the x in these compositions, okay? Moving on to example 2, we're going to apply it. So we have f of g of x. We already know that we're going to do g of x first, and then we're going to have the f of x after that. What does that mean? Well, we know g of x is the same thing as x plus 3. So now what we have to do is we have to plug that into our outer function and get, so we have a result, okay, x plus 3. Okay, we plugged that in for g. We started with inner, got a result, and it was just x plus 3. And now we plug that into the outer function. Okay, so we're going to plug this into the outer function. What does that mean? Well, f of x is the same thing as x squared. So now we're going to put x plus 3 quantity squared. See what we did there? Let me change the color of this, actually. We plugged in x plus 3 into f of x. Okay, so f of x was x squared. There's the squared. But instead of writing x, we wrote x plus 3 because that was what we had for our inner function. It's a little bit easier once we put values in it. So now what we're going to do is we're going to say, we're going to take g of 4 first, and then we're going to take, and for part B, and then we're going to take the f of that, okay? That's equal to, well, we're going to put 4 in for x for g. So g of 4 is going to be equal to 4 plus 3. That's equal to 7. So we have our value for g of 4. That's 7. So what do we do now? Well, we're going to take f of 7. Okay, two different functions here. We're talking about our f function now. F of 7 is the same thing as, well, 7 and then squared, because what we do with this one is we don't want to put the x, we want to put what we got from the g function. So that's 7, and now we're squaring it because that's what f of x is telling us to do for the outer function. Okay, f of x is telling us to square it. So we're going to take this and square it, just like this one suggests, and we're going to get 49 for our answer. This was our answer in number 1. Now you can see that another way to do it is first do the composition with x, because if we just plugged in 4 here, okay, we get 4 plus 3 is 7, and then squared is 49. We get the same thing, but I personally prefer this second method. just going straight to it. Okay, now what happens if you switch it around? Now we're doing f of 4 first. Okay, remember that's the inner function. That's the inner, that's the outer. So we're doing f of 4 first, and then we're going to take g of that. So we're going to plug in 4 for f first this time. They switched roles. So we're going to do 4 squared. That's the same thing as, so f of 4 is the same thing as 4 squared. That's equal to 16. So we get 16, and now we're going to move on to the outer function. This time it's g. So g of 16. Well, now we have to plug in 16 in for g. So g of 16 is equal to 16 plus 3. That's equal to 19. So let me, I don't know why I did it up there, but we have 16 plus, oops, let me write 16 in a different color. So we write 16 plus 3, and that equals 19. And that's going to be our value of g of f of 4, okay, composition of function. This last part, I just want to do a real quick identity function. That's equal, kind of important, but not too critical. We'll go over this a little bit more later, but an identity function is simply a linear function. So this is linear. Okay, a squaring function, this is when you have x squared, and it's going to look like a parabola. Okay, this is technically a quadratic. Okay, so we have something like this, quadratic. And then we have a cubing function, which is x cubed, and it's going to look something like this. Just so you're aware of, you can graph polynomial functions. We're in the polynomial section. This is like the graphing component, and this is a cubic function, okay? So there's 3 different types of functions that we'll go over just if you want to see it visually. The main part of this, though, is composition of functions. Hope you enjoyed this video a little bit long. Thanks for sticking with me. Looking forward to see you next time on Wes Explains Best.